So, hello everyone. My name is Milan Falešník and I work for Red Hat in Czech Republic. And I'm here to show you how to make yourself comfortable and leverage Selenium with Python. Just some short, who am I? I studied at Brno University of Technology and I used to be an intern for Red Hat, and for 4 years I've been a full-time employee. And last year, I was here at Selenium Camp. So that leads us to the next question. Why am I here? When I was at this conference last year, I haven't heard much about using dynamic languages like Python or Ruby in, as a complement to Selenium when testing. So I wanted to share our story, what we did, and the outcome, what came out of it. Usually someone comes and tells you that, oh, this is this tool and it does everything for you, and this is another tool and that also does everything for you, but usually the magic is constrained and you still have to do a lot of by yourself. So what is the baseline for all of this? In Red Hat, we use Python a lot. It's basically a default go-to language. Many tools are written in Python. A lot of integration and UI testing is also happening in Python, and there are lots of Pythonists in Red Hat, so that's just logical. Python is simple yet powerful. It's dynamic language. If you stick to the rules, it's very readable, and it's quite flexible. And some people say that Python is the pseudocode you can execute. Then you can use Python with pure Selenium, which works okay, but it's simple. You just tell it what to do, and it does it like if you did it in Java, but it gets very verbose and repetitive. And there are also some minor differences between browsers, which can make it tricky. So we started like this when our project started, but then we decided to improve on this. And also, Horn already mentioned what we use to run our tests. Some people still use Python unit test, but this has been around a long time, and it's a flexible test framework which uses dependency injection for setup and teardown. So the test or the fixture just declares what it needs, and the framework just gets it to you and ensures the setup and teardown. It is pluginable. It has a lot of plugins for, let's say, Allure and all these things, or lots of things in PyPy. And you don't have to write these assert equal, assert not equal, assert contains, assert greater, which you have like in Java or another testing frameworks, because it just looks at the assert and tells you what was wrong. So, did we succeed? So far, yes, though there were some bumps on the way there. And let's first start what is the product I'm working on. It's called Red Hat CloudForms, or the upstream is called ManageIQ. That's what we acquired 5 years ago, and it's basically a cloud and infrastructure virtualization manager where you can control everything and automate it, police it, scan it, etc. It would be a presentation by itself just about this. So a little bit of history of this story. The ManageIQ was acquired at the end of 2012, and the CloudForms QE subsequently was born, and then we had that first automation, which we like to call Framework 1. Then a year later, we have done a refactor, which was good, but there were also some things that weren't really done well, so that was the basis of the last refactor, which we are having now, and which we actually finished in January. And some people are asking, well, why we are testing on UI? You should just test REST and then have just simple UI tests to ensure it works. Well, I love to. I know the testing pyramid. But when ManageIQ was first written, it wasn't driven by REST, it was UI driven. So there was no API, there was just some SOAP API for very simple actions. So actually integration tests had to be done through the UI. But it's getting better. The rest has been catching up, and now we are using it as well. I will mention that at the end of the presentation. And also UI is being refactored, so when it's the main user interface, you just need to catch all the errors when they pop up. And it's a complex product. So that's why it is how it is, and that's what brought us to this solution we have now. So let's start. First, we used a thing called MozWeb QA. It's now deprecated, and it was basically like if you took the classic Java Selenium tests, you had classes where you store locators, then something which gave you the element, and you were just clicking everything very verbosely, passing around the pages, as you can see, you know, and it all had very long names, etc. So you have to explicitly tell everything, everywhere, lots of repeating. The code also hard codes locations, which then didn't work for us. And there's a lot of repetitions. It's quite difficult to remove in this kind of code. Anyone can fix it, but it doesn't look as good. So then we had the first refactor. We had a colleague coming from a team. He worked with Clojure, which is a Lisp language. And we divided and conquered. So we have declared that there are some pages, I don't know, that have fields with some names and some locators or widgets, which remove the clutter, and you didn't have to write, you know, get the element, click on it, fill on it, because everything was taken care of. So it was separated, and you could reuse it anywhere without inheritance. You just pulled it, and it worked. This is how it worked. We used models, which is a class which represents a thing in the product, and then you have methods as the interactions with the objects you created, updated, deleted. And we had this fill thing, and basically all boiled down to navigate, fill, submit, return something. So we had this navigation where you said you want to navigate somewhere by a string, it went there, did everything for you. And we also built up a library of hex because Selenium was sometimes very quirky. To navigate around, we had this. This was also ported from the Clojure library our colleague had. And it was basically a tree of interactions going from the login throughout the whole UI. So you had Explorer of control, and then you could display policy profiles by clicking on the accordion tree, etc. So it was just a simple call, but it looks kind of bad. And you see that if you want to go from Control Explorer to Control Explorer policy profiles, then you have to click on accordion tree, which is like, doesn't make sense because it's flipped the order. Then you sometimes need to pass a context, like the object you are navigating to, so it can click the object name, for example. Sometimes it was an object, sometimes it was a string, like here. And it's not future-proof. You couldn't, for example, skip steps or backtrack and find out, you know, the shortest path in the UI. And our colleague also brought one thing from Clojure, which is multi-dispatch. He didn't like duck typing. Duck typing is, in dynamic languages, you just tell the object to do something, and the object either handles it or tells that, you know, I don't know what it is, or handles it somehow dynamically. And he brought this library here, where you just fill anything, anywhere. You tell it the locator, you tell it the value, and it just fills it, figures it out by itself. But it was an error. Because if you are bringing some foreign concepts into languages, it's a good exercise, but it can bring you trouble if you're doing in production. It was prolonging state tracebacks, and it was pain to debug because you then had to set up priorities between the different types. It was all madness. And you couldn't reload modules. It's a Python thing. And it was also, the whole system was relying on globals, so it was pulling browser from somewhere. It was pulling some value from somewhere, so then if you had to debug something, it was extremely difficult. That didn't scale, so we met exactly 2 years ago, and we lined out a couple of things we want to solve. Get rid of the global stuff we just pull from some modules. Let's have some sort of dependency injection where you just let the object have what it needs. Improve the navigation. and make fill actually Pythonic. It was really bad before. Then we were also thinking about how to unify REST and UI testing using the same code, which was quite interesting, and I will talk about it later. And make it simpler to make the code uniform, because the code before relied on people memorizing some patterns, and there was nothing to guide them, by design, and also better logging, because if to have logging out of the box, don't care about it. So to represent the UI, I got inspired by Django database model. If you don't know Django, it's a Python web framework, and it has an excellent database model. You basically just define a class, which is the table. You tell what is in the table. You define it in such way, and it just works. And I thought that would be a good thing. So I wrote widgetastic, which you can take a look at on PyPy or on GitHub. And what it is. You just describe the UI using some widgets, mostly declaratively. It offers orthogonal interfaces, so everything is designed that it works on everything. It logs everything that it can possibly log by itself. It also contains the hacks we carried from the first refactor. And you can choose if you want to inherit them or nest them or include the views, which roughly correspond to page objects. And it's standalone. You can just use it with conjunction with any libraries you want. An example of usage of that would be this. You just declare something. This is taken from the tests. You then instantiate it with the browser, and then you start working. There is a read-fill interface, and that's basically to facilitate form filling and etc. So reading will give you a dictionary of keys which correspond to fields and their values. And fill must be able to digest it as well. So if you are playing with it, you can just read, modify something, fill it. It just works. And fill will tell you if it changed anything or not. And you can also access it like it was an attribute. So you do form.input1.something. That works as usual. But the read and fill is everywhere. What we have for features, and some people found them quite novelty, is, for example, version picking. Because there are so many changes in text in the UI that we don't keep separate branches for versions, because we would have a ton of branches. So we came up with version picking, where you just have something which, on the fly, while running, will pick the correct value for you, be it widget or a string, whatever. So if they if they remove the name and there is only a locator, because in Angular you don't need that, it just works even without IDs, then you can add it there, and then you can go complain to developers. Yes, you see, you have to change it 3 times. We have all these versions in there. So that allows us to complain. So you see, in last half year you changed it 4 times. That's not good. And you can also use the version pick as a value when you invoke the actions. Also, parameterized views is a quite interesting thing, because it also allows to interoperate in a REST-like fashion. So the interaction with the UI looks a bit more like it was with the REST API. So it represents repeating patterns on the UI as a dictionaries. For example, you have rows of fields. So you isolate an identifier, which is uniquely identifying the group. Then you just use it in the locators, etc. So you tell it that this thing takes a parameter called name, and you can either specify the root for element lookup like this. You just tell it use the name, or you can use it directly in the widget locators, and you can just invoke it like this, or when you read or fill, it will work as a dictionary for you, and the key to the dictionary will be this parameter. So you don't hardcode anything. You don't have like attribute 1, value 1, attribute 2, value 2. You don't. use parameters as string, and also hooks. We have had a very good success with safety hook. After you do any action to the UI, we have a giant JavaScript which checks everything, like is it stable, not? Because after some action, the UI may be doing something and you need to wait for it. So that slows things down, but it's a good trade-off for reliability for tests. Also, before after fill hooks, you can do some extra stuff if the UI is specific. And also, if you fill something in an input, you can also wait for some action to happen, because that also happens, that you have some Ajax is bound after a timeout to an input. It's not very good. Also, this is an interesting feature, object collapsing. Sometimes you fill values in the UI, and then you don't know, when you're writing a test set, so do I select the user username or the user full name in the select? You don't have to care with this, because you just teach the object to give you the right value, and widgetastic recognize it, and you can just pass the whole object and it takes the value from the object itself. Also, if you have like, if you have, let's say, a select where you select something, and some other widget changes, for example, from input to select, then you don't have to have them modeled as two separate widgets. It can be one, under one name, but it can be switched based on the value of another widget. And it works on all meaningful Pythons, so that's good for future-proofing. And maybe you notice there's no navigation. That's correct, because the navigation was made a separate library. So, if someone likes this library, they can use the library, but they want to navigate in a different way, it works like that. So we separated it in a package called navmazing, which is widgetastic and navmazing. And it was written by my colleague Pete. And in principle, it is doing the same thing, but much nicer, and it also has a couple of other features that make it better. It's basically the old system done in a nice Pythonic way. And it can integrate widgetastic in about 10 lines of code, so it's nice. But first we need to explain the models. I mentioned them before, that you have classes that represent the real objects in the product in your test suite, so you can interact with them. And it's convenient to have that, because then when you use scenarios, it's just easy for you to create that object, create another object, set something up, and then you run something else. But you need to do it right for it to work properly. So first we use that kind of naive, well, not naive, but this is basically what people come up with first. You have a class, you just instantiate it and then you create. But where does it know where is the browser and where is the configuration and where is everything? It has to be global. So then you have to pass something into it, and that's not too nice. So we came up with the idea of collections, which basically is you never really import or instantiate it yourself. You have something that gives it to you as a dependency injection. You have some test session object, some global, which contains all the configuration, browsers, etc. And you have something that gives you the collections, and it creates them. So you tell the domains collection to create a domain for you. And then you can also represent the UI operations. So if you do domain.delete, it clicks on the domain and then deletes it. But if you do it on the collection, then you pass multiple domains, and that can be the operation which happens in the view of all domains. It just checks them and deletes them. Because in our tests, we don't interact with the UI. We just tell it what it should do, not like click on this, click on that. So, why all of this? Navigation uses it. We have designed the navigation, so you register steps against, or locations against these classes. So typically, a domain collection can have all, because it can display all the domains. And also it can have add, because you add it from the collection. Then you assign some views into it. So then when it comes there, it can check that it is indeed on that view, and it can then give the view back to you when you navigate into the location. Then there is the declarative system of telling you what is the prerequisite. Like if you want to go to all domains, first you need to go to this global objects automate explorer, and then on that view you just click there in the path. And if you want to go if you want to add a new one, then first you need to go to view of all and then click on add a new domain. So that makes it quite better to read. And all the classes will have same location numbers. So any class, any kind of object will have details. Any kind of collection will have all. Any kind of collection will have probably add. And as I said this, yes, and it also, when you navigate somewhere, it starts to backtrack, and on the first view, it figures out it's on it. It doesn't go all back to the dashboard or somewhere, it just figures out it's like just 2 steps back. So it just goes 2 steps back and just does the 2 steps. It's readable. So this is how it might work. You have some sort of session object. That's usually the object where you register those global UI locations or something. You have dashboard, maybe you have automate, which is a section in our product, for example. So how to get to dashboard? First you need to log in. Then how to get to automate? First you have to be in dashboard and then click on automate. Then you add a new kind of object, a domain collection, which points to the session object, and collection has all and add. How to get to all domains? Well, you are in the automate and you click on domains. And to add a domain, you have to be in all, and you have to click on add new. And again, you create a domain class, which when instantiated holds a reference to domain collection. It has details on, let's say, tags. So again, to go to details, you need to be in all domains and select the domain. And to go to tags, you have to be in domains details and edit tags. So this is visualized how does all the system work. And it basically backtracks everything. And then, for example, it figures out it's already in all, so it only clicks on the domain, etc. It doesn't reset the UI or anything. So that also adds to a bit of fuzzing to the test, that it never goes the same path. So how does it look now? You have in modal, in collection, you navigate to self-add, because that's on the collection. Then you fill the view with some data. Then you click a button, and then you check if there was a flash message, and then you return the object. And in the test, what you do? You have a test, you use this, we call it appliance, and you go to collections to create it, and then you do what you need. You assert it exists, you navigate to there, and then you assert something in the UI. So then, this is how the test looked before. Was that classic way of, going around, passing pages, returning them from the methods, etc. It was very verbose. And when something changed, everything had a specific name. And if something changed, which developers like to do for some reason, then you have to get someone to change it everywhere. It's not very nice. But that never happens. Developers say they never change anything, but that's just not true. Then there is the last thing, and it's called write once, run many, or as we call it, worm. As I said about the collections and models, etc., you maybe notice that interaction with it quite looks like interacting with the REST API. And that's on purpose, because we have been planning to do this for about 3 years, and now we are starting to do it. So the tests usually do not interact with the UI. They just tell, you have to create this, and then you check it, and it must have this parameter, and then you create something else, and then you delete it. So I was thinking, why don't just have the same test body for testing REST, UI, or you can have another endpoints. Now GraphQL, it's taking all off, or you can have a different UI. For example, CloudForms or ManageIQ has another UI as well, or self-service UI. So you can do the same action in the main UI and the self-service UI, but you can test it with the same, possibly test it in the same test. So we made a thing called sentaku. In Japanese it means choice. And basically you define some endpoints. We have an endpoint called UI, you have an endpoint called REST, or maybe GraphQL, whatever. And then this thing makes a sort of facade for you, and then you can implement the specific things against respective endpoints. And you can also use various strategies. For example, if you are having a fixture set up teardown, you can have a strategy where you pick the fastest one available. So if you have REST available, it uses REST. If REST is not available, it does it through the UI. And then when you're running test, then you say this test must run through REST. And it runs through REST. If you don't have REST, that's a failure. And the next iteration of the test runs with the UI. So you test the same thing. No, you test the same thing in two different endpoints with the same code, and it just gives it for you. That's in early stage, but it's already working. We just don't have resources now to just convert everything. So I'll show an example. Let's say you have a user, and user can be created, right? We have a create method. So you add, if you want to employ Sentaku, you just add Sentaku as a layer in there. So that makes the create a sort of facade in front of this action. And then you implement the action for UI using Selenium. And then you add a different endpoint, let's say REST, and you implement it with a REST, you know. And then you have test running, and you have like three phases. You have fixture setup, then test itself, then the teardown. And for the fixture setup and teardown, you typically want to use whatever is the fastest thing to do. So here it will pick REST because it's available. And then you are running the test, and the test will run twice. First, it will run for the UI. A second, it will run for the REST. And if either of these is unavailable, it's a failure. And then you tear down. Again, the policy is pick the fastest one which is available. So I think that's a conclusion now. So we learned from our mistakes, and we started to iterate in small, how to say it, to go progressively, not just jump into something and figure out that 2 months later it was a bad thing. So we started to plan a lot. So that took us where we are now. We also learned a lot about the technologies we used, all the PyTest, Selenium, Python, everything. We didn't rewrite from scratch. Managers don't like just someone come and say, yeah, we will rewrite it, and then 2 months later you figure out that it wasn't a good move. So everything was done within the current testing system. And all just happened gradually. We were doing our QA testing. We used sometimes you had, for example, a week where you don't have much work on testing because it's after 2 releases. So we could, move on this progress. Engineering is better and specific. We just made these things to be standalone, so other teams could use it. And there are other teams that are now starting to look into it, or maybe already using it. And it's readable. And without experiments, there's no progress. If we weren't unhappy and didn't have 2 perfectionists on the team, we would probably still do something more resembling the first thing, where you just tell Selenium everything in a test. And evolution can happen in circles. You saw that basically what we came up with was just a page object model done in a different way. So I think for us that was a success. And if you have any questions.
Hello.
Hey.
I once used the Mozilla QA. It was long ago. But then Mozilla dropped that and split that to 3 separate packages. And we are now still using this, and I use them as PyTest Selenium, PyTest HTML, and PyTest variables. Why didn't you continue with that, or you decide? Why did you? Because for us, for example, that code was fine, and we moved to using these new split packages.
How was the name of the packages, of the new ones?
PyTest Selenium, it gives just a fixture of the browser into every test and some other tricks.
Actually, we had a meeting about this with a different team, and they were evaluating it as well. But they discovered it just is giving you the browser, so you still have to tell it everything manually. Like you don't have any system behind it that would help you do it. It's just giving you the browser. So that didn't work for us because it's also good to not be bound to the testing framework. It's good that you can just open IPython and just type something yourself and have all the support outside of the test framework, which you can have, but maybe I haven't looked in PyTest Selenium that much, but I know that it's just giving you that fixture with Selenium.
And the reporting, have you left the reporting? Because the PyTest HTML, for example, this part of the former Mozilla QA.
We planned to do Allure, and now there is some initiative to use Report Portal for reporting. But before that, we used our own solution, which also pushed the results in some test management system. So that we used a thing called Artifactor, but it's specific to our framework because it had some features for us that we needed for us to test, but we are planning to move away from that because it's a custom code. We don't want to maintain it, so we're planning to use something out of the box now when it's well
there are
available.
a lot of solutions now.
Yeah.
Okay. Thanks.
Mm-hmm.
Could you please share your plans for widgetastic? Are you going to enhance it? Are you going to turn it into something other, and etc.?
For the API, I think it will not change. Maybe there will be some polishing under the hood. There are some things that could be done better, but it will look how it looks. Maybe some new features added. I don't have any specific plans yet.
Hi, Milan.
Hey.
I was wondering, how do you manage working with preconditions? For example, you have to test step C, but you have to go through A and B every time. Do you do that over API and then continue over UI or something?
Preconditions, you mean like something gets created?
Yeah, previously, so you can don't have to waste some time to go there.
Currently, we don't use that Sentaku thing for it, mostly, because it's not ready yet. We didn't have time to convert everything, but for some things we use REST API where it's possible. So but it's like explicitly saying, yes, we need to create this through REST API. Yes, we use it.
And then
where
switch
possible.
to UI, right?
Sorry?
And then switch to UI.
Yeah, then do whatever you need in the UI.
All right. Haven't you thought about seeder to seed data?
Sorry?
To seed the data directly in the database and then use it over UI.
Yes, we thought about it, but it's a Rails app and they have a lot of, I would say, well, let's put it this way, it's a bit, it can be a bit complicated to see the data correctly. because they
Yeah, I
process
see.
it in the controllers and the models, and they create some value somewhere else. It can be a bit messy to read. Some things we do, or did. We moved away from database because now it used to be a VM. It still is a VM, that thing, CloudForms, but now it's available as a container, and now it's OpenShift pods. They are working on it, and accessing database there is a bit tricky. So we try to move everything from doing stuff in database or through SSH to REST API. We force the developers to give the access to us. So.
All right, thank you.
Welcome.
Hi. Correct me if I'm wrong. You said we are testing API and UI together, actually. But I'm actually curious about how you are represent that API and UI results on the reports. Did you separate these results, or
well,
they are together?
In PyTest, you have parameterization. It's probably also in different frameworks. And basically, you can parameterize any test using some values, and then it appears in the test name. So you can see that this test was run with UI, and this test was run with REST. So you can filter them. You can distinguish them from each other.
Hey, one question about your future plan. You didn't mention anything. What do you want to implement or change or improve?
I prefer not to have a feature creep. So currently, features get implemented when they are needed. I have some plans in my head, but I still need to, crystallize them. But there are like no. We had some plans, but they are not crystallized, so I will not share them yet to improve it or make some like a combination of tools to make it even easier. But from the widgetastic point of view, it shouldn't change, just maybe some features get added, but I cannot tell which one yet.
No questions. No.
Hello, thank you. I had really like your second version. It was kind of page object elements that you define. This is input, this is drop down, etc. My question about is for me your last version of framework is slightly complicated. What profit, and it's more verbose instead of less. What do you think about it?
You need to find a balance between verbosity and capabilities. So the second version with the magic fill, it was less verbose, but it was problematically designed. So we were thinking about the balance between verbosity and usability. So the last iteration, it is more verbose, but everything is crystal clear. You don't have to wade through that navigation tree, and you don't have to think about where the browser is, etc. It's just like straightly defined. Everything is passed instead of pulled from some module somewhere.
What do you think your framework would be intuitive for newbie in Python? They download, read your documentation, and they could start, or it's more complicated?
If they read the documentation with examples, I think they would be able to go through it, but it is recommended that people know some concepts from Python, like for example, I don't know, for example, descriptors, so they understand what actually happens in widgetastic, let's say, or with the prerequisites, like navigate to symboling, what it actually does when you access it.
Yeah, sure.
But for a newbie, if they are giving the template, it's then like, if they know at least something of Python, it's then like HTML template. You get it from designer, and then you just put stuff in it.
Thank you.
Okay, thank you.